Okay, along with the question, I have given a hint also how to solve this problem. So here we are having a given relation R and with attributes A, B, C, D, D, E, F and be a relational schema with the following dependencies, and this F dependency set is given to us. C gives F, E gives A, AC gives D and A gives B. Okay, so which of the following is a key for a, a key of the R? So the solution given is find the closure of set of all options given, and if any closure covers all the attributes of the relation R, then that is a key. Okay, so this is how we are calculating the key attribute. So let me know how we can calculate the key attributes of that is attribute closure of CD, EC, AE and AC, and which of these can be complete relation R can be there. So anyone willing to answer this question? Anyone with the answer? Surely. So okay, as enough time is done, so let us calculate with the closure of all the attributes. So closure of an attribute, it means that whatever given functional dependency set is given, to that we are applying few of the rules. That is Armstrong axioms. So that we are applying on a given set of function dependency set, and then we also apply union, pseudo transitivity and augmentation. So these rules we apply on the given set of functional dependencies. So for this purpose, we to find out which is a key attribute, we need to find out the attribute closure of all the given options. So let us take a first a set of complete functional dependency. This is my given set of functional dependencies. So I will make this as FD equal to set of functional dependencies with this, and let us take a first option CD. Okay, CD I have taken. So CD, to that if I apply a rule of trivial rule, that is this also gives its own if this also points to the same, that is CD, and let us check which are the other attributes covered by this functional dependency. So C gives F. So here a rule of attribute that is closure is that in the every functional dependency we check whether this left hand side is available on the left hand side, and if the right hand side is available not available, we add this to the given list. So C gives F, so I will say F is added. Now see this function dependency covered. E is yet not a part of left hand side, so we can skip this. Next, EC. EC, here the functional dependency, this C is available but E is not available, and hence again we cannot calculate this. D is already added here, but we cannot take.
Ma'am,
Yes,
ma'am,
yes.
sorry for interruption, but your screen is not visible.
Okay. Now is it visible? Actually, I have taken presentation mode, and because of which only presentation was visible. Whenever I skip to the changes, this was not visible, maybe. So is this visible? Okay. So shall I start from the start? Okay. So here, this is a given set. So here, which our question is that here we have given a relation R with these attributes, and this is a set of functional dependencies. And here we are asked to find out the key of the R. Okay, key of the R, it means that which is the element which attribute set can give me the complete R. If the right hand side of the functional dependency is complete R, that is all the attribute A, B, C, D, D, E, F, then we can say that this left hand side is a key attribute. Okay, so for this purpose, we are calculating the closure of attribute set. Now, here we are not going to calculate C's closure or E's closure, etc. For everything, we are not going to calculate. Whatever given options are there, four options are there. For this purpose, we are calculating the attribute closure. Okay, and let us see which are those. So here the first option is a CD option. Okay, so CD option, as we know that this functional dependencies are always trivial. So CD gives CD. Already this functional dependency we will add. Next, if consider this CF left hand side is available in the left hand side, then we can add F to the here also. So F is added. Next, take the second functional dependency. Here E is on the left hand side, but this is not available on the left hand side of the CD. That's why we cannot consider this functional dependency for the further calculation. EC, again E is missing, and AB, A is also not a part of this CD, and that's why we will limit that attribute closure of CD will be only CD, F will be there. Okay, so this is a attribute closure of CD plus. Okay, now this is first option done. So now this is not giving us the complete R. So only three attributes we have covered, C, D and F we have covered, and remaining A, B and E are not covered. That's why this is not a key attribute. Let us move to the second option, EC. And here also we calculate the closure of these. So EC being trivial dependency, we will add EC already. And let us check which are the left hand side attributes with this any whether any functional dependencies existing here. C is here, a part of this option left hand side, and C is also here. So it means we can add F here. The next EA available. So E is also available. It means I can add A also. Next, EC already available, EC available. So it means I can add D also as part of this. And then next, AB. Okay. So we know that E gives A and A gives B. So here we can apply the transitive dependency and can say that as E is giving the A and A is giving the B, so I can add B as a part of this answer. So now let us check whether A, B, C, D, D, E, F, all the attributes are covered here. A is covered, B is covered, B is covered, C, D, E and F. It means whatever the closure of AC is there, that is equivalent to R. And hence we can say that EC is a key attribute or key for the R. So now let me know how many of you had not understood this.
Mom, me,
Yes?
me.
Uh,
I didn't understood it.
which one?
EC plus means
EC plus you have not understood. Okay.
means up to EC means I know means how the EC and AD is came,
Huh.
but how the B's came I didn't understood means.
You didn't understood how the B came.
Uh,
Okay. Okay. This is the functional dependency given. And this is also a functional dependency given. Okay. So now do you think that this right hand side is equal to the left hand side? And whatever this left hand side is there, that is also a part of this. Okay. So as E gives A, I have added A here. And on A attribute, we are having dependency of the B. And hence we can apply a transitive rule here. Transitive rule says that if on the X, Y is dependent, and on the Y, if we are having Z dependent, then we can make the conclusion that on X, Z is dependent. So that was the transitive dependency. So transitive rule we have applied here. On E, A is dependent, and on A, B is dependent. So indirectly we can say that this A got removed, and we can say that B is dependent on the E, and hence we added B to the part of this attribute closure. Now is it clear?
yeah, ma'am, it's clear.
Sure.
Hmm.
So, okay, this was the first problem we have studied. But answer is much more detailed. So, let us see the answer. So, answer says that first algorithm to find the closure state. So, this is the same but divided into steps. Step 1, 2, 3, 4. So, step 1 is equate an attribute or attribute X for the which closure needs to be identified. So, uh, So now we wanted to find out equate an attribute or attributes to the X for which closure needs to be identified. So we wanted to find out first closure for the CD, next for the EC, next E and AC. But we got the answer correct at this point only. So that's why we had not calculated for the AE and AC. So this is the given. So for the FD, this is given say, this is CD plus and EC plus. Next, step 2, take each functional dependency one by one and check whether left hand side of functional dependency is available in the X. So that it means in the CD, as this is my left hand side. So here we are having CF, left hand side is available. So it means we can add F to this in that way. Okay. Same rule. So we will not go this into much more detail. and here the functional dependency, that is the closure, is done. So first for the CD it is calculated, and for the EC it is then calculated, and hence this is covering all the elements of R, and hence we can say that EC is a key element, and hence option B is true for this. Go through this. Okay, done. Shall we move to the next problem now? So, okay, this one is the second problem. Given the following relation instance, x, y, z, three attributes are there, and four rows are there. Which of the following functional dependencies are satisfied by the instance? And again, four options are given. So let me know which one is the correct answer for this. Done? Is anybody coming with the answer or not? At least anybody solving the question? Or is it me only go on giving the lecture?
Ma'am, I have solved, but
Let it be wrong, no problem.
okay, it's A.
A. Okay, anybody else with another answer? See? Anybody else with the another answer? So, okay, let us try to solve this problem. Okay, screen is visible? Yes, it's visible. So here the main point is that functional dependency, it means that whenever we are talking about, it means as the definition says, it means I will use this space for the explanation. So the functional dependency, it means that if there are two tuples are there, okay, T1 is one tuple and T2 is another tuple. Okay, so we can say that there is a dependency of attribute A, that on attribute A, B is dependent. We can say that whenever T1's A is equal to T2's A, then we can say that this functional dependency exists if for T1's B, that must be equal to T2's B. Okay, that is the functional dependency definition. That if two tuples are having same A, it means they should have same B also. So now let us take the example of the first dependency. Okay, option A. Control C. I will copy this. Okay, so this is the first dependency. XY gives Z. Okay, let us see whether XY combinations. So XY, this XY, 1 4 is giving the 2, 1 5 is giving the Z, and 1 6 is giving the 3. It means every combination is unique, and hence we are also having answer as unique. Now, next dependency, Z gives Y. Okay. So, based on the first functional dependency, we cannot make any of the conclusions that XY give us the unique combination, and there is no any equivalence condition between the A values, and that's why we cannot check for the second condition also. But whenever we are talking about the second option, Z gives Y. Let us see these options. So Z is 2, my Y is 4. Z is 3, Y is 5. Z is 3, we are having 6 also. Now let us consider this as my T1 and let us consider this as my T2. Okay. So T1's A, it means Z, is equal to T2's Z. This is correct that we are having Z same. Whether we are having second condition also true, that T1's Y is whether equal to T2's Y. Whether this condition is getting satisfied, T1's Y T1's y is 5 and T2's y is 6. Okay, here we are having T1's z. Here we are having 3 equal to 3, and here T1's y is 5 and is equal to T2's y equal to 6. Whether both are equal or whether the condition for this, that is a functional dependency, satisfied. Yes, you can comment also, no problem.
No, ma'am, no, it's not
No,
satisfying.
yes, it doesn't satisfy, and that's why our first option is not correct. Okay, so here whatever z values are there, or another example we can consider, this is my T1. So then I will remove this T1, and this is my T2. Okay, this is my T2, and let us check whether T1 z is equal to T2 z. Yes, condition satisfied. T1's y is 4, okay, and T2's y is 2. Here also we don't have condition satisfied. First condition is true, yes, both are true too. But what else? Second condition is there. During this period, this is not true, and that's why we cannot make this option as a correct. Okay. So let us jump to the second option. Okay, let us check this condition. YZ. Okay, this combination right now we are checking. So first let us check whether any combination is getting repeated. 4 2 YZ we are checking. 4 2 5 3 6 3 and 2 2. None of the combination got repeated, and hence we cannot make any conclusion based on the first functional dependency. Now directly jump to the second functional dependency. Y Z. What is it? Okay, y and z. So on the y we are having dependency of the z. Okay, so y 4 is there and 2 is there. So in the y none of the option get repeated. Okay, so neither 4 gives 4 is neither there, 5 6 neither 2 is getting repeated, and that's why we can keep this option for our answer. Okay, as both of the condition are satisfied, so we may give this option for our answer, but not yet can finalize this. We should be able to derive those or explain those that yes, these are the true for the any of the cases. Now let us try for the third option. So I will mark this as a bold. So let us try for the third. So first already we checked during the second, this we cannot check, and that's why we let us take an x and z. Okay, x and z, let us take this one is my T1. This is my T1, and let us consider this as my T2. Now let us check, we are checking for this functional dependency. T1's x is equal to T2's x, and whether that leads to T1's z and T2z is equivalent or not. That we are right now checking. So T1's x is 1 and T2's x is also 1. So let us make this 1 1. And let us check the second case. T1's z is 2 and T2z is 3. Okay. So it means that here also we cannot say this functional dependency existing, or other option we can take that uh, instead of taking this two as our second tuple, we can take this also as our second tuple. And let us check our whether first two conditions are satisfied. X T1x and T2x both are correct. 1 1. T1z 2 is there and T2z 3 is there. Okay, again this condition doesn't come true, and that's why we cannot make the conclusion that this pairing is a possible, or this functional dependency is satisfied by the instance, and hence we eliminate the third option also. And let us jump to the last option. So this is our last option, xz. Let us check whether any xz option is getting repeated. So x and z, this combination we are looking for. Yes, xz 1 and 4, 1 and 3, 1 and 3. This combination got repeated. So let us check whether for this combination we are having this same or not. So instead of this T1, we will make this as a T1. Okay, so T1's XZ, T1's XZ, we are having this as 1 3, and T2's XZ also we are having this as 1 3. This is not our T1. And let us check T1's Y is equal to T2's Y. T1's Y is 5. T1's Y is 5 and T2's Y is 6. Now whether this condition got true? Here also we have false regarding this. And on this current discussion and false of all the options, we may make the conclusion that second option is correct. So I request you to go through the question once again and go through the answer also, and calculate by yourself whether the answer is correct or not, or whether any doubt is there in your questions. Take a look for this for a minute. Still we are in the second question only. I planned that at least 10 questions we will cover today.
Ma'am, hello.
Yes.
Ma'am, means the question means what we learn in the theory, it's very different one. Means examples are, I'm confused and means I didn't understood means what to do further hence.
It means I didn't understand what you were trying
Means
to say.
actually, ma'am, we are learning the theory, functional dependency, how it came. It will,
Huh.
means, sorry, it was understood. Means
Huh.
it was all chapter, means we were understood, but the examples are not going to, what we can say, the example are not understanding to us. Yeah, seriously, one single word I didn't get from it, like how it came and means actually I'm trying also means I have taken book and pen with me, but I'm solving as well, but I didn't understood one single sentence.
Okay. No problem. That's why we are having this practice. It means that's why I'm taking these problems to as a part of lecture. So, okay, the first thing is that when we can say that two attributes are dependent, okay, that is the main thing first, okay. So, we can say that any attribute is dependent on some another attribute, okay. So, the let me open with the fourth chapter. Okay, I will open the fourth chapter and let us read the definition of functional dependency from there itself. So, okay, let me know whether you can see the functional dependency slide.
Yeah, ma'am, it's visible.
Okay, so here let us read this definition. Okay, require that the value for a certain set of attributes determines uniquely the value for another set of the attributes. Okay, this is the main definition. Okay, so here we can say that on attribute A, okay, B is dependent. If consider that whenever I'm trying to give A of T, I should get a unique value of B only. म्हणजे याचा अर्थ काय आहे की ज्या ज्या वेळेस मी एखाद्या टपलची म्हणजे एखाद्या अट्रिब्यूटची ए ची एखादी व्हॅल्यू घेते त्यावेळेस मला बी ची प्रत्येक वेळेस एकच व्हॅल्यू मिळाली पाहिजे. Okay, that is the main concept. It means that if consider A मध्ये समजा माझी व्हॅल्यू जर 1 आहे, ओके, आणि B ची व्हॅल्यू जर 5 आहे, देन माझे त्या ह्याच्यामध्ये की कॉन्स्टंट म्हणजे आपण बाजूला ठेवूयात. की कॉन्स्टंट जर सोडला म्हणजे ए पण की नाही आणि बी पण माझी की नाही, तर ज्या ज्या वेळेस माझं ए एकच्या व्हॅल्यूनं रिपीट होईल त्या त्यावेळेस प्रत्येक वेळेस माझी बी ची व्हॅल्यू ही 5च असायला हवी. ओके, असं होऊ नये की एकदा एकची व्हॅल्यू माझी 1 आहे म्हणजे ए ची व्हॅल्यू 5 आहे आणि दुसऱ्या वेळेस माझी बी ची व्हॅल्यू 6 आहे, असं नाही व्हायला पाहिजे. हिअर functional dependency says that require that the value of certain set of attributes, okay, this is referring to A, a value for certain set of attributes determines uniquely the value for another set of the attributes. This means that मेरा म्हणजे ए ची माझी कुठली का व्हॅल्यू असणार प्रत्येक वेळेस मला बी ची एकच व्हॅल्यू मिळणार. मग भलेही ती माझं एकदा रिपीट होऊ देत किंवा 4दा रिपीट होऊ देत, म्हणजे ए माझी व्हॅल्यू डिटरमाइन करते की माझी बी ची व्हॅल्यू काय असायला हवी. So now we will jump to this discussion now. Okay, now I will copy this table to the new slide. Okay, now we wanted to check whether which are the functional dependency sets are existing for this. Okay, आता समजा मी काय केलं की हे जे टपल आहे, ओके, हे जे टपल आहे त्याला T1 अंडरस्टँड केलं. ओके, हे माझं T1 आहे. Okay, this is my T1, and let us consider that this is my T2. ओके, नाव आता मी कधी म्हणू शकते की माझा झेड हा एक्स वर डिपेंडेंट आहे. राईट नाव वी आर चेकिंग फॉर द फंक्शनल डिपेंडन्सी ऑन एक्स whether z is dependent. Okay, this condition right now we wanted to check. That means that if I'm calculating t1's x, okay, that should give me some value of the z. I can say this functional dependency will exist if for the another tuple also I will have the same value of the z. Here माझी x ची जर व्हॅल्यू रिपीट होत असेल, ओके, आणि फंक्शनल डिपेंडन्सी एक्स गिव्ह झेड जर असेल तर माझी झेड ची व्हॅल्यू सुद्धा डिपेंडंट असायला हवी. इट मीन्स सेम असायला हवी. तरच मी म्हणू शकते की जशी माझी एक्स ची व्हॅल्यू चेंज होते माझी झेड ची व्हॅल्यू सुद्धा चेंज होते. जर माझं एक्स जर चेंज नाही झालं तर माझं वाय सुद्धा चेंज होत नाही. In this case, we are having same x1 value 1, y value 2. x1 remains same, but z value got changed. x1 remains same, but z value got changed. And hence we can say that on x, z is not dependent. Now is it clear? Is it clear? Yes.
Yeah, ma'am, it is clear.
Your voice doesn't reflect that. Okay, let us go for
I,
another.
ma'am,
Yes.
okay.
Ask
What
your question.
what I will do once I see by my own, once I once again see your lecture, then in the next lecture I will ask you. Is better to means I have to go through once again once.
Okay. Okay. Instead of going for the next lecture, you can go through the same example again and check whether still you are not getting the answer, etc. Okay.
Okay, ma'am. Okay, no issues.
Please go through this example and let me know whether you can calculate the answer now. Remaining also can give the input whether you are understanding the things or not understanding the things. Got it? Okay. Now let us move to the next question. So this is the answer. So I will make this PPT available to you on the DB drive. I have uploaded the notes of third, fourth, fifth chapter also available on the drive as well as PPTs of the current chapter also. So this PPT also soon I will upload. So here functional dependencies which are not satisfiable, those are given. So now let us move to this question. That is third question. From the following instance of a relational schema RABC, we can conclude that, and four options are given. So A is given ABC. A first option is A functionally determines B and B functionally determines C. Next, A functionally determines B and B does not functionally determine C. Next, B does not functionally determine C and A does not functionally determine B and B does not functionally determine C. So which of these is correct, that we have to mark. So I think by looking at this scenario only, somebody can come with the answer. So I will stop sharing the screen. I cannot go to the chat window. I will share a window instead. So here, okay, we can think for a minute or two. Renuka, I had not received your form yet. I've given time up to 11.
Ma'am,
Yes,
option A.
no. Yes, Tejaswini has come with the answer. Option B. So, how you can make the conclusion? Okay, so let us discuss this answer also. So, option A says that A functionally determines B. Okay, so if we only talk about A and B, then A of one gives B one, one 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 one. Yes, right. That's right. And two two three three. It means for same A we are having the same B. It means first statement is correct. Then now let us move to the second statement. B functionally determines C. Okay, now this statement we wanted to verify. For the B, that is B when it is 1, we are having C as 1. And when B is 1, we are having C 0. But the definition of functional dependency says that some set of attributes determine some other sets attribute unique values. But B of 1 gives me two values 1 and 0, and hence this functional dependency is not shown here. For a single value of B, we are having multiple values of C. Uniqueness is not there, and that's why whatever the second statement is there, B functionally determines C, that is false here. Yes, remaining case 3 3 gives us 2 2, that's correct. But regarding the 1, this statement is wrong, and hence our first option is not right. Let us go through the second statement. A functionally determines B. Yes, that we have checked during the A option also. And the second statement says that B does not functionally determines C. Yes, B does not functionally determine C because for the same values of B, we are having different values of the C, and hence B option is correct. And again, to add confusion to the existing discussion, Gate also adds statements like B does not functionally determine C. Yes, that statement is also correct. But along with that, A functionally determines B. This option is also correct. And hence, option B is taken as a much more appropriate. And remaining option D, that A does not functionally determines B and B does not functionally determine C, that is also wrong. So here there are two options are correct, that is B and C. So there are choices that you may mark multiple answers, that more than one options are correct. In this category, this question is there. So Fiza,
Yeah, means yeah, I have considered means last row of like A
uh,
means 2 2 2 2. That's why I did their mistake. Now I got
uh,
it.
yes, okay. So third option, B and C, both options are correct here. But if you asked answer for only single option, then you can mark for the B. Okay. So let us move to the next. Here option C is there, but actually B is also correct. So now you can solve this, and I expect that you should answer properly and can give me the correct answer for this question. Except Tejaswini and Fiza, nobody is solving the questions, or nobody is even listening also. So this will be the last question of today's class. Whenever we will get the time, we will go for the solving next questions also. May I proceed with the answer? Or anybody is willing to give the answer? Only 3 minutes are remaining. At 2:15 we need to close the class. Done? So okay, I will start with the answer. So here, main thing is that we are having attributes A, B, C, D, D, E, and H are also there in the given set of the attributes. But here, when we go through the functional dependencies, we cannot see E and H on the any of the right hand side. So okay, it means that in order to get the closure or candidate key for the R, we need E and H to be a part of key. Okay, E and H must be a part of key. And as a short, let us go through the answers. Which options are there wherever everywhere E and H are the part of key? So A and B, H is missing, H is missing. Here EH, yes, available, EH available. BCH is available, but E is not available, and hence E is not part of any of the functional dependency on the right hand side. That's why BCH cannot derive as a E, and hence this option also got eliminated, and hence we in the short can make the conclusion that D is a answer for the given question. Okay. So regarding the details, we will see into the next lecture. So have a nice day, and at 3 o'clock, okay, please don't forget to join the Facebook session. And soon I will share a link on the drive. There you should upload your gate examination form. Okay, and those which students belongs to SC/ST category, please upload your forms today only, anyhow. Okay, so thank you all, and don't forget to join the FB live session on this very page. So okay, bye for today. We will meet tomorrow.